direct variation or direct proportion. I would like you to observe the values of x and the values of y as we trace on this point, or as this point traces its path. So I am going to animate this. Now observe the values of x and y as point A is tracing its path. As it is increasing, the values of y were also increasing. Now it is reducing. The values of y are also reducing. It is increasing again, and the values of y are also increasing. So the slope of this line is positive, and that is one of the examples of the graph of a direct variation. Indirect variation, I would like you to also take a second look at the relationship between the x values and the y values as the point B traces its path from negative 1.5 to 1.5. So I am putting animation on, so you see that as x values are decreasing, y values are increasing, and as x values are increasing, the y values start to decrease. I hope you can observe that. So this is what we call an indirect variation or inverse proportion or variation. Once again, the slope of this graph at any point will be negative. So if two quantities x and y are directly proportional, we write y is directly proportional to x. Now this symbol means proportional to, so y is proportional to x, but this relation is a direct proportion. Then if they are inversely proportional, we write y is inversely proportional to 1 over x. So this symbol reads is proportional to. So we have this first one, p varies directly as the cube root of q if p is equal to 4 when q is equal to 8. Find p when q is equal to 64. So we write p varies directly as the cube root of q. Now we introduce a constant of proportionality, so we write p is equal to k times the cube root of q. So k is the constant of proportionality. So this implies that 4 is equal to k times the cubic root of 8. So we're given those values. So we simplify, we obtain 4 is equal to k times 2, which is 2k. So k is therefore equal to 2. So we solve into this relation over here to obtain p is equal to 2 times the cubic root of q. So to find p when q is 64, we just substitute 64 here. So p is therefore equal to 2 times 4, and that is equal to 8. The correct answer is B. If v varies as the square root of q and q is equal to 9 when v equal 3, find q when v equal negative 3. So we have v varies directly as the square root of q. Now we introduce the constant of proportionality k. So v is equal to k times square root of q. Now we start in the values given to us. So 3 is equal to the square root of 9 times k. This implies that 3 is equal to 3k, and this will give the value of k to be equal to 1. So we just substitute over here to obtain v equals square root of q. So when v equal negative 3, then we substitute to obtain negative 3 equal square root of q. So we square both sides to obtain q equal the square root of the negative 3 square, which is 9. Now we have t varies directly as d and inversely as a. Given that t is equal to 6, d equal 3, and a equal 2, find a when t equal 3 and d equal 6. So we have t varying directly, inversely as a, and directly as d. So this is how we write it. Now t is equal to k times d over a. So we have these values, we just substitute them over here. So we obtain 6 is equal to k times 3 over 2. So we simplify to obtain our k to be equal to 12 over 3, which is 4. So k is 4. Now t will be equal to 4 times d over a. So we sub in the second batch of values, which is 3 is equal to 4 times 6 over a. So we are looking for a, so we make a the subject. We just swap their position with the 3. So we get a to be equal to 4 times 6 over 3, and that will give us 8. So the correct answer is 8. If y varies inversely as x squared, how does x vary with y? So y varies inversely as x squared. How does x vary with y? So let's see how we can arrive at that. So let's write the relation y varies inversely as x squared. So this implies that y is equal to a certain constant over x squared. Now we have x squared equal k over y. We are just making x the subject, so we swap the position with the y. Now this implies that our x is equal to the square root of k over the, let me rub this, so square root of k over the square root of y. So this root k is the same as another constant, so it will give us another constant c over root of y. Now we can rewrite this again as a variation, so we write x varies inversely as the square root of y. So the correct answer is B. Now x varies directly as y and inversely as z. When x equal 5, y equal 2, and z equal 1. So we have x varying directly as y. That means x is proportional to y, then inversely as z, so over z. Then this implies that x is equal to a certain constant times y over z, and that implies that we have substitute the values now. So x equal 5, then y equal 2, so then we also have z equal 1. So this implies that our k is equal to 5/2. So now let us sub in this value into this relation to obtain x equal 5y/2. So over 2c. So now to find the value of x, we just sub in the value of y and z. So we have 5 times 5 over 2 times 2, and that will give us 25/4, which is equal to 6.25. So the correct answer is 6.25. So you can visit WASSCE.com for more of these tutorials. Now we have this. Now let's finish with this. W varies inversely as t if w equal 2 and t equal 3. So we have this. W varies inversely as t. Then we have w is equal to a certain constant k over t. So we sub in the values. So we get 2 is equal to k over 3. So k is equal to 6. Now just sub in the value to obtain w. So w will be equal to 6 over t. So when t is equal to 24, we get w equals 6/24, and that will give us 1/4.